Today we're going to look at when functions are linear, quadratic, or exponential based upon tables. The EOC will give you tables that look like this, table of values, and ask you, does this function represent a linear, exponential, quadratic equation? So remember, linear is lines, quadratics are the U-shaped parabolas, exponentials are kind of like that L-shaped curve. Now, theoretically, we could take these points, we could graph them, and we could look at the shape of the graph. And when in doubt, you can absolutely do that. The problem is some of these points are going to be very, very large and not fit on the graph. Like the point 723, we can't fit that on a normal graph. Or like in the exponential example, 728, we can't fit that. So to get a really good picture of this, we're going to look at how does the table look for linear, quadratic, and exponential. We're going to look at the differences. What I mean by the differences, we're focusing on the y values. I want to look at how the y values change. So, how would you get from 2 to 5? You're adding 3. So this is a plus 3. And if you don't know what that number is, take the 5 minus 2, and that would give you 3. How do we get from 5 to 8? How do we get from 8 to 11? Is this plus 3 all the way across? If the y values are increasing at a constant rate, increasing or decreasing by the same amount every single time, that is linear. So the first level of differences are the same. We're increasing by 3. This is a linear example. Now let's look at what happens when we do the same thing in one that we know is quadratic. We know it's quadratic because it's listed as the quadratic example. How do I get from 0 to 1? Add 1. How do I get from 1 to 4? How do I get from 4 to 9? 9 to 16? 16 to 25? You're starting to see a pattern? What I want you to notice is those numbers are not the same. Not the same. So it's definitely not linear. Okay, now here's the crazy thing. We're going to do this again. We're going to find the second level of differences, the differences of the differences. How would I get from 1 to 3? We would add 2. How would I get from 3 to 5? Plus 2. Are all of these plus 2? The first level of differences are how the y values are increasing. The second level of differences is how the differences in the y values are increasing or decreasing. If the second level is the same, it is quadratic. So I'm going to write next to these are the same. The second level of differences are the same, so it is quadratic. This is actually really, really related to the equations. In a linear example, it's just a plain x with no exponent. It's kind of like an exponent of 1. So the first level of differences are the same. In a quadratic, we're looking for x squared, a 2. So the second level of differences have to be the same. All right, now let's look at exponential. From 1 to 2, that's adding 1. 2 to 4 is adding 2. How do you get from 4 to 8? 8 to 16 plus 8. 16 to 32 is plus 16. If you don't know, the next one, 64 minus 32, this would be adding 32, and this one would be adding 64. Are the first level of differences the same? Not the same. Now let's try the second level of differences. Second level of differences, we'd be adding 1, adding 2, adding 4. Wait a minute. You notice anything weird? The second level of differences are not the same. Is there anything else you're noticing except for the fact that they are not the same? Look at the actual numbers. 1, 2, 4, 8, 16, 32. 1, 2, 4, 8, 16, 32. 1, 2, 4, 8, 16, 32. Do you see how it's just repeating itself over and over and over? If it starts repeating itself, we could continue to the third level of differences, the fourth level of differences, the fifth level of differences. That pattern would continue repeating itself. That's classic in an exponential example. The other thing you can check, Lizzie actually asked a minute ago, why didn't we multiply? Look at this pattern. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Sometimes it's very obvious that it's multiplication. If it isn't obvious, check the differences. But what you might notice is it's actually multiplication. The pattern is happening with multiplication. That means it's exponential. So, to recap, in a linear function, the first level of differences are the same. Constant is another word for same. In a quadratic example, the second level of differences are the same. And for exponential, it says the y values have a common ratio. I want you to put next to that multiplication or repeated pattern in differences. So when we find that first level of differences, second level of differences, whatever, you're seeing those same numbers popping up over and over in the same pattern. If you see that pattern happening over and over, you might think, wait a minute, this might be multiplication. Let's check multiplication. Oh, look, it's an exponential function. For these examples, we need to decide, are these tables representative of linear, quadratic, or exponential? So the first thing that I'm going to do is check differences. So 11 to 8. How do I get from 11 to 8? Minus 3. How do I get from 8 to 5? Are these all minus 3? They are. That means it is linear. The first level of differences are the same, so I'm going to point an arrow and say, hey, these are the same, so it's linear. Okay, B. I'm adding 1, adding 2. I immediately know it's not linear. Adding 4, adding 8. So I know that this is not linear. Is the second level of differences the same? Plus 1, plus 2. Okay, definitely not quadratic. And I'm seeing that same pattern happen over and over again. 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4. This is exponential. With exponential, you can also check, is there a multiplying pattern? 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, example C. Negatives can be kind of difficult. So how do I get from -1 to -2? Minus 1. -1 minus 1 is -2. But then how do I go back from -2 to -1? That would be adding 1. Now let's say that you're really struggling with that. You can always do the second number minus the first. So -2 minus a -1. That means we subtracted 1 between those. -1 minus a -2. We added 1 to get between those. How do you get from -1 to 2? Or count on your fingers. Think about a number line. Start at -1 on the number line. To get over to 2, be adding -1, 0, 1, 2. That'd be adding 3. And from 2 to 7, how do you get from 2 to 7? That'd be adding 5. So if you need to, think about a number line. So to get from -1 to 2, 1, 2, 3, that's adding 3. To get from 2 to 7, you're adding 5. Okay, so are the first level of differences the same? No, so it's not linear. We can cross linear out. Now let's try the second level of differences. How do I get from -1 to +1? +2. How do I get from 1 to 3? +2. And from 3 to 5? +2. That means this is quadratic. I want you to try the bottom two on your own. See if you can figure out the bottom two completely on your own. We'll check them in a couple minutes. If you're watching this video, you should pause the video, try these two problems in your notes, and after you've tried them, play the video to check your answers. Don't just stare at the screen absentmindedly. Try these examples on your own. So far, I've figured out that both of these are not linear. So I've completely eliminated linear as an option, not linear. Here's the problem. I know that 1 plus 2 is 3, and 3 plus 6 is 9. 9 plus, I don't know. I don't know what I would add to 9 to get 27. So I try 27 minus 9 on my calculator, and it tells me that that would be adding 18. 81 minus 27, this would be plus 54. Definitely not linear. Next level, 2 plus 4 is 6. 6 plus 12 is 18. And then plus 36, this is telling me it's not quadratic. What's the other option? Exponential. If it's not linear and not quadratic, it's probably exponential. And then we could check multiplication. Think about multiplication. How did you get from 1 to 3 using multiplication? This would be times 3. Is 3 times 3 9? Yes. 9 times 3 is 27. And 27 times 3 is 81. That means that it's exponential. The last one, I know it's not linear. And this is kind of weird when it switches to negative and then switches back. So really just think about 12 minus 12 is 0. 0 minus 4 is -4. -4 plus 4 is 0. 0 plus 12 is 12. Definitely not linear. Okay, if I was on a number line, to get from -12 to -4, I have to add 8. To get from -4 to +4, I have to add 8. And if you need to draw out a number line for yourself so you can figure this out, go for it. Here's -4. Here's +4. That's 8. And from 4 to 12, that's adding 8. Because the second level is the same, this is quadratic.